welcome to Ladyada.
Hey everybody, and welcome to another Sunday night, yet another week in the bag. It's me, Ladyada, at my desk. With me, Mr. Ladyada on camera control.
Hello.
Thanks for running this thing. We got a bunch of stuff going on this week. Some new stuff, some revisions of old stuff, some stuff is getting lost, some stuff is getting revisited. First up, I do want to mention, if you wanted Feather RP2040s, we made a whole bunch on Friday night. So go and pick them up.
Scroll around.
We're scrolling.
Yeah.
So, I'm logged in as a reseller, so you see reseller pricing or discount pricing. But we're letting people pick up as many as 10. They're in stock. There's lots in stock, and we're also going to get some to distributors. We had our initial first run about a week and a half ago, and
there may be no more by tomorrow, so may as well just go.
Yeah, they are going, but we do have some, so you don't have to like rush. But after our first initial run, we manufactured a whole bunch for the second run, and so far so good. So those are in the shop. And speaking of RP2040, today I successfully tested and finished the QT Py RP2040 design, which is, I think I've got the coming soon here. So a couple upgrades were made to it, updated the flash memory to 8 megabytes. I finally found some Exxon 8x8 flash memory. I got some ordered, tested it. Looks good. I also got the USB boot button to work as an input. So it's used for bootloader mode, but then after bootloader mode is completed and you're launched into CircuitPython or Pico SDK, you can use it as an input button, which is, kind of poor taste, but, why not? Let's stay punk rock here. Keep it punk.
Yeah, one quick question. Is there any changes between the first run and the current run of the 2040 Feather?
No, there's no changes. We just wanted to make sure that there were no changes. There are some ideas I have for a next revision. Some very small changes. Again, maybe making that USB boot button act as an input. Maybe adding pull-ups to I2C pins. Maybe changing the SWD to through hole. But these are nothing would change the functionality. It would just be adding or improving some experience stuff. But so far, people are seeming to like it. I'm also going to listen really closely here if there's any other feedback that comes in. Because it's a new chip. I'm learning about the RP2040, which is very exciting. And so I'm getting ready to do more designs, becoming more familiar with this chip so it's easier for me to manufacture with it. So let's go to the overhead, and I'll show off the So this is the RP2040 QT Py. Here's another one I've got. Maybe I'll just show this. So it's super small. It's got USB-C. It's got, again, like a boot button, reset button, Stemma QT connector over here. Let me grab my USB-C. I think this has some rainbow loaded onto it. Yeah, there you go. It's got a little neopixels running my demo code. You've got power and 4 analog pins, and then 9 GPIO pins total here. And then you have 2 more GPIO pins extra on the Stemma QT connector. You get 2 I2C ports. And on the bottom, there's the chip. We've got 8 megabyte flash QSPI crystal. And, Bill B asked me to put a little jumper so you can short USB to 5 volts, and I did. So that's not for most people. You want to have that diode protection. But if you want to back power USB because you want it to be a USB host, you can do that too.
For the Feather, there's a Rev B on GitHub and one with no Rev. Which one matches the current one that we're shipping?
The current one is the Rev B.
Okay.
Yeah, I think.
And then I think someone requested pull-ups for I2C. I don't know which board they were.
For the Feather, I can do it. For the QT, there's no space, so I can't. But, you might also want to use it for something else. So, maybe you want pull-ups, maybe you want pull-downs. So the Feather, I might add them, but here's the thing. All of our I2C breakouts have pull-ups on them. And it's also, while the Raspberry Pi itself has pull-ups on I2C, most Arduino boards don't. It's actually a little bit unusual, unless they have onboard sensors. So that's why I tend not to put them on there. But maybe I will. We'll see if
Okay, and you went with USB-C on that?
On the QT Py, yeah. The QT Pys get USB-C. That's
All
kind
right.
of their deal.
Feather is
USB-C.
USB-C. Why'd you go with that and not? mini?
Well, mini is definitely, quite old at this point. I definitely don't make any boards with mini. I do use micro sometimes, but a lot of people are starting to get USB-C. It's reversible. It's kind of nice. You got it this way, and then you can reverse it, and you got it that way. It is a nice connector. Not had any problems with it. It seems to be reliable. It's a little tougher to solder. It's a little more expensive. It's a teeny bit bigger than micro USB. There's a few cases where I want to maintain compatibility, like Circuit Playground Expresses. If I'm making Circuit Playgrounds, I'm going to have only micro B. Why? Because the case only fits the micro B, and I don't want to redo the case. So for those, I use micro B because there's still a lot of micro B people and capable in the world. But for new boards, USB-C seems to be working fine. And here's it running, Circuit Python, and I've got this cool round rect display that I picked up. Let's see.
That's a screen protector on there, by the way. That's not how the screen looks.
No, I know, but hold on, it's not coming up, and I wonder what happened. Oh, there you go. That's weird. So this is a rounded rect. Oh, you know what? There's probably a loose connector, and I keep hitting it. Hold on, let me reset. Okay, so this is a rounded rect display. So you see this rounded. It's rounded rectangle output, but it just means it's cutting off pixels that are in the corner. I think these are used for low cost watches. It's an SPI ST7789 display. It's 280 by 240, so I'm just designing a breakout for it. So far so good. It's kind of cute because it's got this, it's rounded rectangles. Who doesn't love rounded rectangles? But you just have to be careful because you have to avoid putting things in the corner because of course they'll get cut off. Because it's the screen is still there. It's just blacked out. So in theory a bezel would do this too, but I guess you do have. Here it looks like this probably continues, but over in the corner you get a nice rounded corner here. That's kind of nice. And then if you have the REPL running, you see it just cuts off the pixels in the corners. So you only get a little bit of the prompt here. Kind of interesting. But that was my demo, just running the QT Py and trying it out. But seems to work pretty fine. I just have to figure out what my soldering is doing over here that's making this so sad. But that's a new screen I got, and I put a breakout together for it. And then I'm experimenting also with, for I2C devices, we have the Stemma QT connector, right? This 4-pin, power ground, SCL, SDA. But for SPI devices, like e-inks and screens and SD cards, I thought it could be nice to have a Stemma QT-like thing, but for SPI. And Phil and I chatted, and I said, well, should we have a cable or a flex display? Or a flex cable, or a Pico blade cable. And I kind of thought about it. We're well, there's so many pins. A Pico blade cable actually would be it would start getting a little spaghetti. And then we noticed that DF Robot was using these flex cables on their displays. These are 18-pin FPC cables. They're nice and slim, and they have plenty of pins. So we're going to start adding them to our displays too. We're going to use the same pin out because they did a good job. So I'm going to just do what they did and make it compatible. Rather than trying to come up with my own thing. And so this could plug into a Feather maybe, or a Raspberry Pi, the flex cable on the other side, and then you wouldn't have to do all the wiring because there's so many pins on SPI displays. By the time you get the backlight and the SD card, and if there's a touch controller, there's just so many pins. Having a standard cable would be cool, and then you could use any display with any of our driver boards. So I think that'll be something we start doing, but this would be probably the first display to come with that. So rounded rectangle displays, and then our current name that we think we're going to call this is iSpy.
Yeah, calling it iSpy.
iSpy.
Yeah,
okay.
An eyeball, I.
Because you're looking at stuff.
iSpy.
Displays.
It's all about displays with SPI.
That's right. iSpy. More news on my desk. This has been on my desk for a while. The IMX RT 1011 Metro, and it's actually a year now. But so is the Braincraft. That took a year too. Some boards some boards need to marinate a little longer. The good news is that we're actually getting back to this. We were getting ready to do it in December, November, December we started, kind of gearing up to. We added some support to CircuitPython for the IMX chips, and we were working on the bootloader and getting the bootloader, TDUF2 is sized and all that. And then, we kind of got this email from the Pi Foundation saying, hey, there's this new chip we're releasing. Do you want to get in on it? And that kind of like blew away like 2 or 3 months. All good, but basically, December, January, and February were taken up by the RP2040, which is cool. I mean, QT Py, feathers, more to come. CircuitPython support's great. And we want, the Pico board, of course, there's, now over 100,000 of them in people's hands. So we kind of diverted our attention a little bit to that launch. But now that the RP2040 is actually doing quite well, and we feel like it's a very solid position, we're kind of turning around and going back to the IMX. So this is the first IMX board, the Cortex M7 running at 500 megahertz. It's very speedy. It only has about 128 kilobytes of RAM, and a bunch of that is used by the cache because it uses QSPI memory, a lot like the RP2040, which is coincidental. But as these chips get more powerful, you do see off chip execute in place more often because people need a variety of different flash memory sizes. So instead of baking it in, you have it externally. Also, if you have a lot of RAM, you can just put the instruction cache in RAM, and it's nearly as fast as having it on flash, but a lot cheaper. So this one has 128K of RAM. It's not tons, but we got it to do a bunch of Wi-Fi projects in CircuitPython. You're able to do it. You can, because you have a huge flash memory, you can put a bunch of libraries in flash instead of loading them into RAM off disk. So it's got Airlift, SPI, to Wi-Fi and Bluetooth LE. You've got SWD, you got a simple power supply, on-off switch, Arduino Uno size, and pin out. There's lots of pins, so plenty of pins. Stemma QT connector, neopixel, and again USB-C. Maybe I'll see. I don't know what demo this is running. I don't think it's running any demo. I think I was just messing around with it. But we've got the USB bootloader going, so that's good. There's also boot flag pins here, so you can always use a command line utility to load code. There's a ROM bootloader, but you have to kind of it's not trivial to use. You have to use a little tool to load code. And then after the RT1011, we're going to do the RT20, which is, kind of the same, but has like twice as much RAM, and I think it has like a couple more peripherals. I think it maybe has like CAN bus, for example. So that shouldn't be too difficult because it's just like a little bit more, and the chip's a little bigger. And then we're going to take the leap from there to RT50 and the RT60. And those are maybe familiar to people because they're used in the Teensy 4 series. So we're going to have probably a Metro and a Feather with these chips running CircuitPython. And hopefully we'll get some of the support for the really cool advanced peripherals that come with those. There's a TFT, there's cameras. These have high-speed USB, which is like really sweet. We can start doing high-speed USB stuff like audio and video within CircuitPython. So this is going to be a very interesting family of chips from NXP that we're going to be exploring. Starting with the RT1011, we're going to start small and then build our way up until we get to the 1060 or the 1070. Once you get to the 1070, it's basically like a Raspberry Pi Zero. It's running like a gigahertz, and it's got like some ridiculous amount of RAM, and it's a very powerful processor. But then again, that's kind of fun. Maybe we can make a board that can run Linux or CircuitPython, right? That could be kind of neat. So stay tuned for that, especially folks who like the IMX series. We'll be adding support for all these chips soon. I mean, we actually have I'm surprised. The support we have is quite good, but we'll be adding more, I think, this week. PWM IO and UART if we haven't done it. But we already have like SPI and I2C and analog inputs. A lot of stuff is already working. So good stuff. So that's the IMX. Any questions about IMXs?
Doesn't look like any questions.
Okay, cool.
But I'll just say this.
USB-C.
Yeah, I think it's neat that you can be part of a cool open source hardware and software community where all this stuff gets published. And also you see and hear about the roadmap of a complete product line we're doing.
Yeah, I mean, like what's interesting
I
is
don't
like
recall another show like it.
we actually, I tell you exactly what we're working on. It's like, people are like, why didn't this get done? I'm like, the RP2040 came out, and like basically that took up a bunch of our time. So maybe I'm just checking my list because I want to make sure. So we got to the IMX. Okay, the RP2040. Okay, so let's talk about more mechanical keyboard stuff next. So next on mechanical keyboards is we've got some stuff coming on the way, including these adorable. Oh wait, hold on, let me get the key. I got these adorable little key caps that are like little silicone pads, but they're like little feet. They're like rubber cat feet. So these and other cute keypads. So just testing out different mechanical keys, and this is going to be the first breakout we have. Is going to be just for one key to use in a breadboard, and then we'll build on that. Talking with some folks about maybe making it easy to add a bunch of keys using I2C. So we thought, okay, well maybe 4 keys is kind of a good number, and this is a seesaw board. So this is using a SAMD09 as an I2C converter. Folks who know we've done. We did a 4x4 neo trellis, elastomer encoder, elastomer keypad with neopixels in it. And so, this is not too unusual. It's like instead of elastomer keypad, we're just using mechanical keys. So this will have sockets. So this one is like socketed, so you can plug in your favorite types of MX compatible keys. It has neopixels for each key. The neopixels are the wrong way. They'll be pointing up and not down, but that's okay. We have A. We're getting there. And right now it's just running an I2C to neopixel demo. And so the next thing I have to do is get this key switch inputs. And something went wrong with my compiler, and I updated my compiler to ARM GCC 11 or something. The last time I compiled this code was, I think, GCC 9. Something changed, probably I have a bug, and it got kind of papered over with an earlier GCC and maybe some uninitialized memory or something, so I have to figure out why it's not working with a modern compiler, but I think I will be able to do that. And then you'll be able to chain these together, read inputs, blink the neopixels to underlight the keys, and you can make simple mechanical keyboards, not full keyboard obviously, but you want to make a little control surface. You could use this to craft that, and then we can also have maybe one with rotary encoders and one with potentiometers. So I think that could be kind of fun. We make little plug and play stackable interface boards. Fun, blinky, cutie. And then lastly, okay, yeah. So lastly, we showed off the Trinkey a few weeks ago, and it's actually going to the store soon. And so Phil and I were thinking about other animals that live in the Trinkey species
Trinkyverse?
collection. The Trinkyverse.
The Trinkyverse.
Trinkyverse. So there's Trinkey, and then we were thinking about Rotary Trinkey, and this is actually because we saw Toddbot kind of basically put a rotary encoder on a QT Py, and I was like, oh yeah, that would be kind of useful if it was just USB to rotary encoder. So this is it's not a correct thickness PCB, so I soldered onto the USB connector, but it's a USB A, and it just goes to a rotary encoder, and that's it. There's a neopixel on the bottom, and this is a rotary encoder with a knob, and it can also be a switch.
Yeah, one thing we did on Boing Boing, there was a video post of the most pausable scenes in Star Trek universe.
Should I go there?
No.
How about we just go to the Adafruit YouTube?
Yeah, I think that's better.
Yeah.
'Cause otherwise, there'll be YouTube issues.
Yeah, that's kind of weird.
And what's neat is you can advance frame by frame.
Okay, so what's a good video for me to do that with?
None really offhand. I would just pick one. And,
Okay, let's go to this one.
Yeah. And
Okay.
Yeah, if you want to just do that with roll it back so you
Okay,
can see.
so what I've got here is this is an HID keyboard. It's just got CircuitPython code to act as why don't you go to the computer and I'll show what
Yeah, why don't you?
So
Yeah, go back and forth.
So
Video.
hold on, let me see. This is let me open up Notepad so I can. So what happens is that when I rotate this forward, it presses the period, and when I rotate it backwards, it presses the comma, and when I press the button, it makes a space. And those are actually YouTube like commands. They're not. They're just like key commands that let you pause. So when I pressed the button, it paused, and then as I rotate the encoder, I can go forward frame by frame, and then I can like kind of go forward and back by rotating. So I'm like rotating the.
Yeah, let me go to the overhead real quick. Someone wants to know, does this show up as a generic HID device?
Yeah, this is a keyboard. I mean, it's CircuitPython, so I just loaded our generic HID code into it. So I also did a version that does volume up and down, but of course I'm not going to do that because I don't want audio to mess up our streaming.
What's cool is you can edit the code right directly on this device and change it to do anything you want. And so one of the things that we really like with CircuitPython.
Yes, this is it.
Which also runs a Circuit Playground. Is CircuitPython, not only do you get USB with it, you get all these cool libraries, you get the ability for it to show up as a drive, you can use any IDE, but all of it is also keyboard. You can make it a keyboard.
Yeah, so this is the, hold on, let me, I think it didn't like that I opened and closed the device. Uh-oh. Hold on. Let me try again. My computer has been very sad about what I've been doing to USB lately.
Oh, yeah?
Yeah, it's a little like, why are you plugging and unplugging things? Okay, so let me move this over here. Oops, over here. So, yeah, if it's running CircuitPython as I press the button, and of course it's typing into the code area, but it's just running CircuitPython. So if you want to change what it presses, like here I just have it press period, and here I have it press comma, and here I have it press space. But you could customize it to volume or other key commands. But it's just like all it is like you plug it into USB and you get a little rotary encoder, and that's it. So I thought Rotary Trinkey.
Okay.
So it's part of the Trinkey family. So as I was doing this, we were talking about rotary encoders, and different types of rotary encoders, and I was like, oh yeah, that would make a great search. So.
Where in the world is that part I need? The great search with Digi-Key.
The Great Search,
okay.
Brought to you by Digi-Key and Adafruit. We do these every single week. Ladyada uses her superpowers of the Digi-Key site to search for the things you need. This week is Rotary Encoder.
Right, so this project here, this is a little USB to rotary encoder doodad that I put together. Super fun for just, you plug it inside of your laptop and you've got a little knob. Rotary encoders are neat because they go all the way around, as you see here. Unlike potentiometers that only go, from minimum to maximum, maybe 270 degrees out of 360, this can go round and round and round and round. There's a couple of trade-offs. One is it's only relative. You don't know where it's pointing. This has a little pointer on it, but that pointer, this doesn't know where that pointer is pointing. All it knows is like it went left one, it went right one, or clockwise, counterclockwise, or Widdershins, or whatever the opposite of Widdershins is. And another thing is that it's not smooth. It's got little detents, or at least this one does. And you can't hear it, but there's a little bit of like a tick every time I move it. It only moves a couple, it only moves into certain orientations. It's not smooth like potentiometer. Another thing you can customize is how many of those little ticks, detents, there are per rotation. So this one has 24. I have like 24, but there's ones that do 12, there's ones that do more. 12 and 24 are kind of the most common though. One thing that this rotary encoder has that is really nice is it's got a clicky switch built into it. So, I can see I'm pressing it. The hat goes down just a little bit, but it's a nice clicky switch. If you're an engineer and you have an oscilloscope, there's like 18 rotary encoders on a scope. This is the D shaft. Why is it called D shaft? Because it's kind of like a D shape. Note that some rotary encoders have T18. They have knurled shafts. You got to pick one or the other. Rotary encoders tend to have D, and potentiometers tend to have T18, but if you want to use a knob from a potentiometer and a rotary encoder or vice versa, just make sure that the knob matches the shaft, because you can tell this is a D shaft, there's a D shape cut out. And then if you have a knurled or T18 style, it looks like a little star with 18 splines on it. So just something to watch for. But we're gonna look for a very common rotary encoder. Again, we want one with detents. I like the detents. I want it to have the switch built in. I want it to have a D shaft, and I want it to have 24 detents per rotation. So to the Digi-Key. Let's go. Okay, so let's search for encoder. So one thing to note, encoder means a lot of things, a lot of encoders in electronics. So we do want the encoder category, but when you go here, you might be a little like, oh my goodness, what are these things? What is this? This is not what I'm looking for. These are huge. What's going on? These are, industrial encoders for motors and servos. So just, be aware, like the same thing that you might use and twist and turn to set your FM station or to adjust your the user interface for your oscilloscope is also used in motors to tell what the rotation and orientation is. And they are different. I mean, they're similar in concept, but they're often a lot more expensive, and they're kind of huge, and they sometimes use optical or absolute orientation, or they're magnetic, not mechanical. We just want a simple mechanical encoder. So the way you you can scroll down and eventually maybe you'd find one, but there's also, this is, I don't know. Basically, there's all these massive encoders. But other than active, we always like to pick active. What you want is called so there's all these different types over here. You see these types over here. We want quadrature incremental, or sometimes called incremental, but in this case it's called quadrature incremental. What that means is there's 2 pins, and so you're like, wait, there's 2 pins, why is it quad? It's because each one can be high or low, and so you have 4 total states. 2 high or low for each switch, and there's 2 switches, 2 times 2, 4, quadrature. And incremental, because you, again, only know when you're turning counterclockwise or clockwise. You don't know the absolute location. Are there situations you want absolute encoders? Yes. They're not going to be $1 or $2. They're going to be quite expensive. Okay, so then let's click accept to apply all. Okay, now we're starting to see, these are starting to look a little bit more like what we want. And there's, a ton of different encoders. Like this is a, common style. Note, you see this one has the T18 knob. I can't mouse over, but if you look at the knob, it's got like knurls on it. Whereas if you look at this one, it's pretty clearly got the D shaft. It's a cut circle. Okay, so next up, let's look for ones that are in stock right now. And okay, so we have a couple options here. Again, I want the built-in switch. You pay a little bit more for built-in switch, but I like it, so let's get the switch. And detents. I like detents too, so let's pick that. Next up, there's 2 different orientations. You can have them stick out, or you can have them stick up. For this project, for the USB rotary Trinkey, I want it this way, which is vertical. This is a right angle, so let's go vertical. Oh, what is user selectable? Oh, because it got wires on it. Yeah, okay, that's cool. Yeah, that's fair. It is user selectable. Technically, that's true. But we want vertical. Okay, so we're starting to pare down the options. I think we have
what's the width index?
The width index.
Not width as in wide. Width as in width index. I guess it's a
width index. Sorry, where do you see that?
I don't know. That was a question from the chat.
Oh, sometimes. Well, I don't know exactly what they're referring to, but see how this one has a little bit of a a nubbin that sticks out to the right. It's kind of like right above the 3 pins. There's a little bit of a nubbin. That's often called the indexer. Like it's a little index nub, and it helps seat it into. Like this one doesn't have that nubbin. It's hard to explain what it is, but you'll know when you see it. Oh, this is kind of cool. This one is translucent. You can have LED shine through. I don't see others with a nubbin, but okay. So let's, sorry, gotta get back to thing. Okay, next up, pulses per revolution. Again, you can choose how many. Note that there's a bunch of options, but really there's only like 12 and 24. Those are I don't really see a lot with others. So let's do that. Okay, looking good. And then rotational life. You'll pay more for rotational life as expected. You know, it sort of depends on whether, you know, how often people are going to be tweaking the thing, do the math on, you know, expected use per day. I will say that, you know, my old oscilloscope, not this one, but the selector knob for the first channel, the yellow channel, the rotary encoder did eventually die because I was using it, you know, maybe like an hour a day up to, I'd be setting the scale for the first channel, and eventually it did get really flaky, and so, you know, I now have to kind of just hold it in the right way when I twist it. Hopefully I'll replace it. Maybe one of these Desca Lady-Adas, I'll do that. Okay, next up, so we don't want knurled end, we want flatted. I don't remember the diameter, but I'm going to just pick these two. I don't want the illuminated, although that's like super cool, maybe some other day. And then at this point, I'm kind of like, nothing else really matters. I want mechanical for sure. Let me pick mechanical. Optical, extremely reliable, more expensive. They use optical switches. And then let's just sort by price. And, you know, you can see that you can get ones with kind of like this little stubby, or, you know, slightly stubby or longer shafts. This one has a panel mount screw, so it's threaded. Whereas this one does not. It just depends on what you want it to look like. If you have it sticking out of a panel, you don't want those threads because it could not look so great. But, you know, this one is inexpensive, and, you know, maybe I would pick this one to start. Price is about $1, and it goes down to about 60 cents in quantity. And it looks fine. So you'll see it's got the 3 pins here. Those are the switches. So there's a common, and then A and B are used as the rotational detection, and then up here is the separate switch. The switch, when you press into the shaft, it closes those 2 pins. And so yeah, I think this is going to be a good, looks, you know, it's kind of a generic, but a good rotary encoder. Depending on your needs, you know, keep looking around about, you know, how many detents or how many pulses, whether you want detents, you want illuminated or not. Lots of rotary encoder options. It's a very, very popular user interface. So that's the great search for rotary encoders.
Where in the world is that part I need? The great search with Digi-Key.
All right, I'm going to do a couple questions and we're going
Okay,
to bounce.
that's right.
Question for the rotary USB.
Yes.
Thoughts on a small switch so you can make the rotary switch have 2 functions, A and B, or volume and rewind or fast forward?
You know, I thought about it and we chatted about it, but we decided actually to keep it simple, and it only does one thing. Where, you know, and you can always load code onto it.
Yeah, one of the things they were thinking of is that allowing that functionality, but when you press it down is what you're selecting modes, essentially.
Yeah, you could do that too. I mean, like it's completely programmable. Like Phil and I were chatting, like, oh, you could do a double click or something to change modes. You could write code to detect a double click. But I also, you know, and we were also thinking about, like, oh, do we want capacitive touch? But then, you know, the more we chatted about it, we sort of decided, like, let's just have it do one thing.
Okay.
You know, not try to be funky.
Do you make sure there's an E-card model on those, or do you make your own? It's an E-card model.
I have no idea what an E-card model is, so I don't know. A mystery.
Okay, I'll go over here.
Okay.
The index on encoder is usually the AZ band that only has 1 spot in the rotation, mostly commercial.
Okay. Sorry, so that's a different kind of indexer. I was thinking of like a rotary potentiometer. They have, you know, they're called like, sometimes they're called indexers. like a
Yeah.
little index.
Was there horizontal and perpendicular ones?
They do. I mean, they make ones that stick out to the side. I happen to want one that sticks up because I want it to like plug into, your laptop, and then the nub, the knob is like this. You twist it up and down.
ECAD, I guess. Do you need to make sure there's an ECAD model, or do you make your own?
Oh, I just make my own. They're all very similar, and that's not that complicated. Most rotary encoders are about the same size.
Eagle footprint, yeah. Okay. I think that is everything. All right, well, if you want feathers, RP2040s will be gone really soon, so get them, and we increased the limit to 10.
Yay!
So go ahead and get them.
All right, thanks everybody. That was
And
my
with that-
Jessica Ladyada, so keep tuning in.
Oh, one question. Is there plans for a rotary wing?
No, not yet. But I'm thinking about different ideas of how
Yeah.
to. I mean, it's the thing about rotary encoders is you have to. There's a significant amount of code you have to write for them, and so if there was one, I'd have to make sure that every platform has
Yeah.
code for and I'd have to write an example. And I was thinking that's when I might just say, hey, we'll make a little I2C adapter for like 2 or 3 rotary encoders in a row. Like that could be kind of fun.
And then someone mentioned we could have named it Cutie Spy.
No, because I think that's confusing. I feel like the QT is for quick compatibility. I didn't want to make something that was too similar to Stemma QT.
Yeah, we say Stemma and Stemma QT.
Yeah, because I gotta be careful because like people see a word and they think oh, that all works together. So
Yeah.
we're still working on the SPI stuff, but ideas.
Okay. All right, folks, like the rotary encoder for a keyboard I2C would be cool, and chance for 2 encoders on QT Py.
You can have 2 encoders on a QT Py. There's enough pins.
Yeah.
I mean, you'd have to just wire them up and then write the code for it. But I think
All right.
CircuitPython supports it.
So that's it for this week. You'll see us on Tuesday, JP's product pick. Wednesday, 3D Hangers with Noah and Pedro. And then you'll see us on Show and Tell. And then you'll see us on Ask an Engineer. And then JP's Workshop. And then Deep Dive with Scott.
On Thursday.
All of our other videos that we're going to do.
Colin's Lab Notes coming out.
Colin Lab Note each day during the week. And more.
And more.
All right. So thank you so much, everybody. Thanks for supporting Adafruit. We'll see you very soon.
Thanks, everybody. Have a great night and a wonderful week.